Good morning, everybody. Welcome to the first V Foundation Virtual Scientific Symposium. We're so delighted to have you with us in this first experiment we're going to have. So I hope you'll bear with us if we have a few glitches, but want to just let you know that we're glad you're here. We've got a very interesting day planned for you, a morning session where we're going to talk about the Stuart Scott Fund, and the afternoon session where we're going to talk about the Robin Roberts Fund. And I'll be explaining both of those to you in a few minutes. But just want to say thank you to some of the wonderful grant-making partners and funders that we have in this endeavor to fund more cancer research that's really relevant to the times. Thank you to Bristol Myers Squibb, who has been a partner all along in helping us fund disparities research, in helping us fund all kinds of important research. And thank you to ESPN, who has been a partner with us since the founding of the V Foundation, to Robin Roberts and her guests at the annual evening with Robin Roberts, and also to the Scott Hamilton Cares Foundation. And if you're with us for the afternoon session, you'll also be hearing from Scott Hamilton. Want to tell you a little bit about this morning's session. And in this time, I mean, we've been planning this symposium for a long time, but at the current moment where we are all being called to recognize that Black lives matter, and we at the V Foundation want to even ramp up our efforts towards looking at the disparities in cancer research, in how cancer disproportionately affects people of color, and also to support the careers of young minority investigators. And that's why we started the Stu Scott Memorial Cancer Research Fund 5 years ago, shortly after Stu passed away. I think many of you know who Stu was, but we will talk about him also a bit later and hear from his sister, Susan, and his daughters, Taelor and Sydni. Since we started the program in 2015, we've awarded more than $10.5 million. And I'm happy to announce today that our wonderful partners at Bristol Myers Squibb are awarding another $1 million towards that grant program. And together we're challenging all of you to help us do even more towards the end of making disparities in cancer care, as well as disparities in healthcare, as well as racism worldwide, a thing of the past. The Stu Scott funds have gone to comprehensive cancer centers around the country. These are very competitive grants, and we asked each cancer center for one application for both our young investigators and for translational grants. So the young investigators are people who are new in their career and who are beginning to contribute in a major way to the research that we have ongoing and in the world of cancer on various different topics. And the translational grants look at some of the reasons that we find for differences in both incidence of cancers and also why there are disparities in that lead to some cancers being even more fatal in different populations than in others. So I'd like to just share a few housekeeping notes before we begin. One is that our technical hosts are able to control the audio and video for everyone, all of the panelists. No one needs to be moving on and off of video or audio because our hosts, our technical hosts, will take care of that. You'll see on the slide a number that you can call if you're having any technical issues. It's truly a live human being who will talk to you about what you might need. And I will then, we are going to have a Q&A at the end. And you'll see that at the bottom of your screen, there is a Q&A button that you'll be able to use to answer questions at the end of the session. And again, we will take those live and ask them of the various presenters. If you have a specific presenter that you would like to ask the question of, let us know. And if you have a general question, let us know and we'll field it to the appropriate scientist. Now I would like to introduce a wonderful clip that ESPN has helped to make that shows some pretty important people speaking the words of Jim Valvano's remarkable 1993 ESPY speech.
To me, there are three things we all should do every day.
Number one is laugh. Number two is think.
Number three is you should have your emotions move to tears.
Think about it. If you laugh, you think, and you cry,
that's a full day.
Cancer can take away all my physical abilities.
It cannot touch my mind.
It cannot touch my heart.
And it cannot touch my soul.
The Jimmy V Foundation for Cancer Research.
Its motto is,
don't give up. Don't ever give up.
All right. So I hope you enjoyed that little clip as a way to get started on what we're doing. Now I would like to introduce to you Jacqueline Blandy from ESPN. As you know, the ESPN is a founding partner with the V Foundation. So after Jim made that speech in 1993, that very night they announced, he and ESPN, the creation of the V Foundation for Cancer Research. And ESPN has been our wonderful partner and our amazing supporter for all of these years. Jacqueline is in the corporate citizenship group there and is with us day and night, working on our efforts to achieve victory over cancer. Jacqueline, would you please say a few words?
Hey, hi everybody. I'm Jacqueline Blandy. Thank you, Susan. You have been such an incredible leader and collaborator. And as you know, we consider you part of the ESPN family. ESPN is honored to be part of today's summit, especially during these unprecedented times. We're so grateful to the V Foundation staff, their board. Gosh, there's so many people to thank, the scientific committee, the researchers, donors. Everybody is really committed to achieving victory over cancer. Last year, ESPN had an incredible milestone. We announced at the ESPYs that we have raised or helped raise over $100 million for the V Foundation. So you can imagine how important the partnership with the V Foundation is to ESPN. It's part of our history. It's part of our culture, and as we always say, we can ask any employee to do something for the V Foundation, and they really drop everything that they're doing to help out. So our mission at ESPN is quite simple. It is to serve the sports fan anytime, anywhere, and our purpose is to use the power of sports to inspire social change. And it feels really relevant at this time with the pandemic and all the social unrest that's happening in this country. It's really taken a toll on human lives. It has interrupted our business. It's literally stopped sports and suspended large gatherings. And I know for all the people on this call, the most important thing is that it has interrupted cancer research. So that is why ESPN really is committed to the V Foundation moving forward. We want to use our voice. We want to use our platforms to really help vulnerable communities. And I have to say, it's really a moment like no other. COVID and cancer has affected African Americans disproportionately. So tackling health inequities is really a top priority for ESPN. As Susan mentioned, 5 years ago, we started the Stuart Scott Fund, and he really is one of the most recognizable African-American broadcasters of all time. So really happy to be ahead of that curve. Stuart was really a dedicated friend to the V Foundation long before he was diagnosed with cancer. He was dedicated to improving outcomes for African Americans who have higher death rates than other populations when it comes to different types of cancer. As Susan also mentioned, we are proud that we have helped raise over $10 million for that fund. And as Susan always says, we can't raise enough for the Stuart Scott Fund. So one ways in which we do raise money for the Stuart Scott Fund is through the Sports Humanitarian Awards. And it's typically a dinner that happens the night before the ESPYs. but we've obviously had to pivot this year. So if you tune into any of our studio shows at ESPN, you'll see stories of hope and inspiration and how sports really impacts communities, and that's beyond the playing field. So particularly proud of that, and that will lead into the ESPYs this Sunday. So with all this change, I think what really comes with that is innovation and reflection. So certainly as we are gathered here today, there are so many doers and dreamers on the call, and I think if we all work as one team, we're gonna really see a difference. And I'm gonna end with a public service announcement that we just created for this year's ESPYs.
We need your help. I need your help. We need money for research. It may not save my life. It may save my children's lives. It may save someone you love. And it's very important. We are starting the Jimmy V Foundation for Cancer Research. And its motto is, don't give up, don't ever give up.
Okay, thank you so much, Jacqueline. We're still getting used to all of the technicalities of this. I know we have another clip that we're going to roll later, but that one is really beautiful. And Jacqueline, your words just truly resonate with what we're here to do today in this partnership. And again, I just want to say that although this work is extraordinarily timely, we've been doing this for many years, but it's been timely for decades and decades. I'm delighted to introduce you to one of Stuart Scott's sisters, Susan Scott. Susan is a remarkable woman and an awful lot of fun, as was her brother. I know you're going to enjoy hearing from her. She lives right here in the Raleigh-Durham area. She works at UNC TV as the Chief Development Officer, and she is just an all-around amazing woman. So, Susan Scott, welcome to our seminar.
Thank you so much, Susan Braun. Give me just a moment. I'm going to share my screen. And in the meantime, as I'm doing that, let me just say that sounds like everybody can hear and see me, which is great. If not, someone speak up and say, yep, excellent. I want to caution you that you might hear a train in the distance during my comments. That's just the one sound that I can't get rid of that one. Susan, thank you. Thanks to everyone associated with the V Foundation for that really sweet introduction and for asking me to speak with you today. Given our nation's current social tinderbox, people can erroneously think there's some kind of Olympics of suffering as they try to make sense of today's world. In the V community, we understand that suffering and surviving takes many forms. It is our shared humanity that drives us to seek equitable solutions for all cancer suffering and to improve survivorship. It is inspiring to know that the V Foundation has been working on the cutting edge of exploring disparities in cancer and survivorship through groundbreaking research for years, as Susan just stated. No conversation about the Stuart Scott Memorial Cancer Research Fund would be whole or complete without a look at Stuart, the person, the man, the brother, son, and father. I've included a few illustrative family pictures to accompany my words and to add dimension. Notice as a toddler, he is holding a pipe in his mouth. Folks, it was the 1960s. He idolized our dad and wanted to be like him in almost every way. Luckily, Dad stopped smoking pipes, which freed Stuart to stop wanting to smoke pipes. Can you imagine if our dad had been a tightrope walker in his spare time? I would have liked to have seen Stuart in that. Stuart was such a force, and I want to spend our brief time together looking at something many of you are very familiar with, his well-known ESPYs speech. I'd like to illustrate parallels between that speech and the research and strides being made as a result of this Memorial Cancer Fund through the lens of loss, lessons learned, leverage, and leadership. As you've heard from Susan and we'll hear from many others, loss is present in all of our lives today. The state or feeling of grief when deprived of something of value. Across the globe, people have lost the opportunity to be together in person. We've lost habits and behaviors that we counted on, and communities have lost people. Loss is sobering, and it can sometimes be debilitating, but it can also be enlightening. I believe it is critical to mine loss for lessons and to use what we learn through loss to improve either ourselves, our companies, our families, and our research efforts. I believe it strengthens us and provides a form of leverage that builds the resilience that's needed to grow beyond where we are today. When I think of loss in the context of V and Stuart, I go back in time 5 years to that July ESPYs night. In his speech, Stuart amended some things he'd said in the past about living and fighting. His only goal had been to live and achieve victory over cancer. But that night he said, "When you die." He and I discussed his death many times in the 7 years before, but he'd never publicly acknowledged the possibility of his death. He dealt with the inevitable loss only rarely and only privately. But that night, he put it on display and put us all on notice. He was acknowledging his loss. Well, let's look at the V Foundation. It was Jim Valvano's cancer fight that inspired the creation of this important organization, an organization that he founded to achieve victory over cancer. It was his impending loss, a loss shared by Stuart and the million soldiers strong army of cancer warriors, patients, researchers, doctors, families, caregivers that stimulated him to seek ways to beat this dreaded disease. Okay, what lessons learned did Stuart convey that night? Remember his words, "I can't do this, don't give up thing all by myself"? He acknowledged that night how much he leaned on others to get through. He alludes in his speech to the fact that he shouldn't have been able to be there that night. You don't know that he cried in his shower before that ESPYs and asked his God to give him the strength to get through that night. You also don't know, but maybe gleaned, that he was concerned that other cancer fighters might hear his fight, fight, fight mantra and words and imagine at the times that they were low and struggling, that they might somehow not be strong enough or fighting enough because they weren't doing it the same way he seemed to be successfully fighting cancer. He learned and acknowledged that fighting required help, rest, and realism. Well, what lessons has the V Foundation learned? So many. But in this fund, the foundation has learned so much more about the role of genes and genetic mutation differences in the fight to eliminate cancer disparities, with breakthroughs in understanding, for example, colorectal cancer in African Americans. That's just one broad lesson of the example of the many lessons learned. Stuart's leverage in the ESPY speech is twofold. Actually, it's multifold, but I'm only going to talk about 2 points. At the beginning, he tells you that he's normally been on the other side of this award, so of course he should know how to do this, giving it out. But at the end, he speaks of family, people dear to his heart, and reminds us that he is every person, and just like anyone, because his loves were essential to his being. He leveraged his awareness of the source of his limited strength, and he leveraged the trust that he'd created in his career by always being matter-of-fact about his cancer and by always presenting a brave and honest face. In the Stuart Scott Memorial Cancer Fund, the organization has leveraged Stuart's drive to improve outcomes for African Americans and other minorities disproportionately affected by cancer. Within this fund, researchers are leveraging what has been learned about genetics to understand, in some cases, how environmental factors, whether it's diet or smoking, perhaps exposure to environmental carcinogens, also contribute to disparities in outcomes. How do we develop treatments for Black and brown people that prevent them from dying disproportionately faster when they are diagnosed with certain cancers? And What applications might that yield for everyone? Now, let's look at Stuart's words in the context of leadership. For many of you, you were there that night. That night was a beacon. It was a clarion cry. Have a great rest of your night and a great rest of your life. He led in showing us all how to live. His leadership has paved the way for raising and awarding more than $10 million for this fund. And there have been numerous past grant recipients, translational grant recipients, V-Scholar grant recipients, Thrivership grant recipients. And while there have been many past examples of leadership and progress by grant recipients of this fund, today, I would like to extend my thanks and thanks from many members of my family on behalf of any cancer fighter anywhere to Akinyeme Ojasina, whose work focuses on the tumor ecology paradigm to facilitate the development of diagnostic biomarkers and predictive models for early detection, prevention, and treatment of certain cancers. And Gianna Hammer, who happens to work right here in Durham, shout out, Bull City. She's engaged in the study of microbial communities. She studies the roles of dendritic cells to understand the breadth and depth of how those cancer cells relay signals from the microbiome, and has studied dendritic cells in colorectal cancer. And thanks to the other grantees, thank you for your efforts to identify gaps in research and treatments. Thank you for your leadership in the name of the V Foundation and the Stuart Scott Memorial Cancer Fund, all of your work to find cures. And I've got one more thing. And that is this. I think about the ironic parallels between Jim Valvano and Stuart Scott. As a young sports reporter, Stuart interviewed Jim and came to know, respect, and admire him. Jim and Stuart were both exuberant about the people and things they loved, especially sports and especially North Carolina basketball. Now, they pulled for different teams, but they had mad respect for their rivals. They were both family men, and fortunately or unfortunately, when they were alive, they were both loved and hated. Now they're both just loved. They both burned bright, fast, and were extinguished at young ages. And yet, they both delivered magical, soulful, charging, and inspiring words in the winter of their lives. And yet, they both live on. In their children, sure, but in their continued ability to inspire us all to keep working to achieve victory over cancer. I'd like to thank you again for inviting me to speak, and I will now turn it back over to the rest of our program. Thank you.
Susan, thank you so much. As always, you are so articulate and you bring it right to the important points of what we're doing here. Thank you so much. Our next presenters, the first is Dr. Akinyeme Ojasina. And I got to meet Dr. Ojasina at one of our V-Scholar summits. And I must tell you, in addition to how wonderfully bright he is, which you will hear about in his research, he is equally as delightful a human being. And I know that anyone who comes in contact with him and his work is blessed by his presence. So over to you, Dr. Ojasina.
It's such a pleasure to be here this morning. And I'm really grateful to the foundation for the funding, which has really allowed us to do things we otherwise would not have been able to do. So my laboratory focuses on the interplay between genetic mutations and microbial factors in cancer. Today, I'm not going to talk about any of the genetic mutations at all. I'm going to focus a little bit more on some really interesting things going on in the microbiome space. So by now, most people have heard the term microbiome, really, and it really in a very simplistic way, is a broad spectrum of microorganisms that are within or around a location. I use the word location because, you can actually have microbiome of the subway, a microbiome of, anywhere these days, actually, in that sense. But with respect to the human body, we've got microorganisms. And by the way, I may use the terms microorganism, microbacteria interchangeably here. We've got them all over the body. And for the most part, many of them are actually not harmful. And so the idea we started playing with was, well, a lot of studies have been done on what we call the gut microbiome, and lots of associations with various diseases have been found. And so what we thought was, what if in fact we could study the tumors themselves and ask whether, one, is there a microbiome in the tumor? And by now, some of this is known that there is. And secondly, are there any bits of information you can glean from them? And so that's really what the question here is. Does the microbiome within tumors play a role in the prognosis of cancer? And so I have a question, really. Imagine you have a bunch of metallic paper clips in gray and plastic paper clips in red, and you wanted to separate them. What would you do? You probably would use the magnet. The magnet will pull up the metallic paper clips and leave the plastic ones. This sort of simple principle is what we've applied to identifying microbes, where we perform high throughput sequencing of human tissues, and then we take those sequences and we align them. We look for what is similar to the human genome. And then when we do that, we're able to identify things that are not like the human genome, and then we can sort of investigate those further. And so we've applied some of that, and we have a pipeline that we use to do that in a process we call computational subtraction. And we've used that to identify microbes of various types in both health and in disease. So I kind of knew that there were going to be people from Espn here, so I thought I would use some illustrations that were related to sports. And so I actually went and I dug up information about the 2020 NFL Combine, and I asked this question: can we actually predict a player's position based on their performance at the Combine? So I looked at only those who had information on these four categories: the vertical jump, the broad jump, the 40-yard run, and the bench. And so basically asked, could we see any similarities or differences between them? And indeed you can. So what I'm showing you here is what we call hierarchical clustering of data. Red means the number is high, blue means the number is low. And so what you see there's a bunch of players right here who did really well with the vertical jump and with the broad jump. There were a few people here who did really well with the bench. Red here for the 40-yard could actually be a bit misleading, because high or large actually means they're slow, right? So, and with that sort of, you probably can't see too clearly here, but anyway, you probably see a lot of OLs and DLs here. So it turns out that actually there is a relationship between the performance of a player at the NFL Combine relative to others and what their position is. I know that really is interesting, where you're able to take information about a group of people, a group of circumstances, and look for relationships between them. It turns out that this type of analysis that I just showed you has actually been applied to various cancers. And for the rest of the talk, I'm going to focus on some of the work we've done on breast cancer. And so basically, using what I just showed you now, we can do exactly the same thing with breast cancer. And we can classify breast cancer based on the abundance of human genes in every tumor. And so it turns out we have, depending on the study you're looking at least 5 types of breast cancer based on the types and the abundance of human genes. And in this particular case, we decided to take a look at this publicly available data set from the Cancer Genome Atlas, shortened as TCGA. And we decided to basically look at that data to see if we could find relationships with microbes and that data set. So you have lots. This pie chart here is just showing that there are 5 to 6 types of breast cancer, and these are just the relative proportions. And so what we did was we took the sequencing data, we used that computational subtraction method I described earlier to pull out the human sequences. We identified what the microbes were, we counted them, and then we performed this clustering analysis, which I just told you about. Now, before I continue, it turns out that remember, we said you can classify based on human gene expression. So I thought, well, let's do another thought experiment. Once again, let's get back to football. So imagine that we already knew from the previous slide that you can actually classify players based on their performance at the combine. That makes absolute sense. But you now ask a question, can you actually classify them based on their diet? You would say, wait, diet? I don't think so. So, and let's just assume for a moment that we actually have 5 groups that we're able to classify them into based on their diet. And then we get this is another way of showing that clustering where you've got, the offensive line somewhere in there in black, you've got safeties out there in red, you've got cornerbacks out here, etc., etc. You've got running backs out there. And then let's assume that we just had the information on the fact that maybe some of them ate a lot of ribs and others ate carrots, steak, broccoli, and milk, or, and you would be surprised to find out that, it looks as if you look at this table, as you can see, it's not perfect. Everybody eats everything, but it looks as if a large number exists here. Offensive line eating ribs, safeties eating carrots, tight ends eating lots of steak, etc. And so you would think, wait. If we're seeing this, maybe in fact there is a relationship between the diet of the players and their positions. So it turns out that using this type of paradigm, we essentially applied that to breast cancer. And what we found was exactly very similar. So we basically took the breast tumors, we clustered them based on their microbial content. And then when we did that, we got this result actually, right? And then so what you're looking at here is 5 groups that are distinguished based on their microbial content, but we have colored them based on their original gene expression groups. And when you do that, you get this type of data where you've got the 5 types of breast cancer, and you've got 5 different clusters based on microbes. And what we see here, once again, is you see the largest number on this row is this. The largest number on this row is this. The largest number on this row is that. So even though they don't sort of fit really neatly, it turns out that there is like a majority subset that seems to be associated with each type of breast cancer. And so we take that data, for example, and we decide to do something interesting. So this is exactly the same table I just showed you. And then we asked, what if, so we thought, well, so these groups are in red, we call them the concordant group, meaning that they were similar between breast cancer based on human gene expression and a majority group of the microbes, of the microbial abundance. So basically said, what if we compared this group right here to all the others? Would we see any difference in their prognosis? Indeed, what we see here, so the red here corresponds to the red there, is that those who have this set of concordance that I described to actually do better in overall survival, in disease-free survival, than those who don't. This is kind of result that will make Scott say, booyah, And so we're working a lot more on this, trying to understand how microbes that are present within tumors may actually play a role in how cancer will develop and the prognosis of patients. So there's a lot that's going on in that area, and we're investigating what roles that might play in how patients respond to therapy. We're looking at racial disparities as well. And with that, I want to say thank you to the foundation for the funding that it provided, and members of my lab, other colleagues at UAB, and colleagues at other institutions who we've worked together as well. So thank you so much. I will be happy to take questions when it's time for questions. Thank you.
Okay, so thank you, Dr. Angesina, so very much. That is fascinating, and I love the booyah moment. Thank you, indeed. Our next presenter is Dr. Gianna Hammer, who I've also had the opportunity to meet at one of our V-Scholar Summits, another rising star who we think the world of. She too is looking at the microbiome, and in this case, what's going on in the intestinal tract. So without any more introduction, because she is the best one to tell you about her work, Dr. Hammer.
Good morning. I am Gianna Hammer. I'm at Duke University, and together with the V Foundation, we are battling against colorectal cancer. So The whole world appreciates our immune system for what it does. Now, it fights against foreign invaders. It fights against virus, it fights against bacteria, and as one of our most recent Nobel Prize laureates now determined, it also can fight against cancer. And in this dynamic, one immune cell is really key for this, and that's the dendritic cell. The dendritic cell's job is to detect foreign invaders. It can detect cancer, it can detect tumors. And what they do, they take this information and instruct immune responses. And the kind of immune cell that's key here to instruct is the T cell. The T cells are the executioners. They eradicate pathogens, then they can eradicate cancer. And T cells come in different flavors. And if you want the best kind of executioner, you want a T cell that makes a protein called interferon gamma. And the same kind of theory of hierarchy, of who's better at the job, goes also for the dendritic cell. They also come in different flavors. And the one that seems to be key for killing cancer is the one in red, which goes by the name DC1. So DC1 is known to be the champion against skin cancer, pretty well studied and well appreciated. It's also the champion against lung cancer. And our question has been then, is it the champion against colorectal cancer? And this is not simply a question of going down the checklist and asking this cancer yes, this cancer no. Colorectal cancer occurs in your gut, and your gut is so unique in that it's full of food, it's full of mucus, it's full of bacteria, fungus. All these environmental influences are unique to and just sitting right on top of the tumor and play a big role in helping the tumor grow, or maybe even also helping the tumor be eradicated. So we want to study this unique context of cancer and the role of dendritic cells in it. We do this using a mouse model. Mouse are helpful to us because they can also get cancers, and then it allows us to test there are certain roles of different immune cells. So this is a picture, an image of a mouse colon. And what you see by the white arrows are tumors. Those are spontaneous tumors that happen in this altered genetic background in this mouse. And what we have been asking then is looking at a normal mouse, a mouse that has all its different dendritic cells, and comparing the outcome of tumors from a mouse where we specifically take out our DC1, specifically take out the dendritic cell that we are thinking is going to be champion. And the idea here, of course, is that if you take out DC1, and if it's truly so important for fighting this battle against colorectal cancer, you would expect you take it out, and therefore you'll get more colon tumors. So what we first did is we take that tumor out and we ask whether or not the dendritic cells can even get inside. And this is what an image of the different dendritic cells that enter the colon tumor really look like. So there are different flavors. You see some population here, another population here, but in this area is where we have the population of DC1. And we made a mouse where we take DC1 out, and sure enough, that population is missing. So our champion is gone. But the outcome was quite surprising. So the number of tumors in mice that have DC1 and the other dendritic cells was more than the mice that we took our potential champion out of. And we had several mice that actually has no tumors whatsoever. And when we quantify this tumor number, here are control. Control means has all the different, we did nothing else different. It has all its dendritic cells. And here's the mouse where we take that, our potential champion. And so again, it was a surprise to us because we thought this would be important in killing tumors in the colon. But if you look at the data says the number of mice that have no tumors whatsoever jumps up to 25%. And if we ask about mice that have 4 or more tumors, that number of mouse is very, very low if we take out DC1. So it surprises. It suggests that what we thought was going to be the champion is actually promoting colon tumors. So what we know about DC1 in skin and lung cancer is that it has this special relationship to make T cells that produce this protein interferon gamma. And those T cells are definitely anti-tumor. And coming now to the colon tumors, this unique environment where food and microbes and all these other foreign components can play a role, then we're asking, does DC1 actually have the same job? Does it make anti-tumor interferon producing T cells? And also, what could it be doing to promote tumors? So the first component of the question, it was straightforward to answer. So we just looked in the tumor and asked about T cells that produce interferon gamma. We quantified them. And so what we found actually was that the number of interferon gamma T cells in mice that have all the dendritic cells and mice that where we take the dendritic cell out, it actually was no difference. So it doesn't look like this DC1 is important for making the anti-tumor response, which is quite different than how it behaves in skin and lung cancer. So we turn our attention then to asking, what could it be doing to promote tumors in the colon? And here it becomes important to realize that T cells can come in at least two flavors. We know that the interferon gamma flavor is important for killing tumors. And there's another flavor that's really, really prevalent in the intestine. Actually, it's mostly lives in the intestine. And that's the kind of T cell that makes the protein called IL-17. We asked about how many IL-17 T cells can actually be in a tumor. And it turns out that a healthy colon has a moderate amount of IL-17 producing T cells. But inside the tumor, this number swells and it really just takes over the population there inside of the colon tumor. And prior research has really well documented that unfortunately, this cytokine, this protein, IL-17, causes colon tumors to grow. It makes them get bigger, and it even can cause some of the mutations that are driving cancer in the colon. So we asked whether or not we take out the DC1 and asked about changes on IL-17 itself. And sure enough, when we take out what we thought was going to be a champion, IL-17, which helps tumors grow, actually goes down. We asked about what T cells are then important for being controlled by DC1. And here's where we had another turn of events that also surprised us. So the relationship between DCs and T cells is mostly described for what we would consider a conventional T cell, which fall into this category. We call them CD4. And so those T cells do enter colon tumors, but they were not different between our control and mice that don't have a DC1. However, another flavor of T cell can make IL-17, and it's a weird T cell. It has a weird looking name. This symbol means it's a gamma delta T cell. It's a weird symbol. It's a weird T cell for reasons I'll go into in just a minute. But what seemed very clear was that the number of gamma delta T cells that can make IL-17 very clearly went down when we take out DC1, meaning that making a pretty seemingly clear relationship that what DC1 is doing inside of colon tumors to promote tumorigenesis and cause colon tumors to grow in colorectal cancer is expanding the number of these funny T cells called gamma delta T cells that make IL-17, gamma delta T17 cells. So through a set of experiments, we learned that when DC1 enters the colon tumor, so this is your intestine here, a cartoon representation of a tumor. When DC1 is inside there, it's putting out come hither signals, much like a very scary head coach calling you out and telling you, come here. This is how the immune system cooperates and listens to what dendritic cells say. So in this case, the dendritic cell is calling the gamma delta T17 to come hither. And we also know that it's causing those cells to proliferate rapidly inside that colon tumor. And this protein that these gamma delta T cells are making, IL-17, is just feeding tumor growth. And this come here signal we learned is actually so strong that it's attracting a crazy rule-breaking gamma delta T17 cell into the colon tumors. And what I mean by this rule-breaking gamma delta T cell are those that come from adult life or non-fetal life. So gamma delta T cells are interesting and weird. For one reason is because they are made before you are born. They come during fetal life. They enter the intestine, again, in the fetus. They enter other environments where they know microbes are going to be needing to be controlled. And so they're there as sentinels to make sure that infections can be controlled. And again, they come during fetal life. And so once a person is born and also on into adulthood, no new gamma delta T17 cells come out. It's totally something that happens inside the womb. And what we learned was that colon tumors contain these rule-breaking adult origin gamma delta T17 cells. And we distinguished between the two and found that yes, in colon tumors, we do have the ones that are conventional, the ones that come through fetal life. But it seemed quite clear that while the healthy tissue didn't have these adult origin gamma delta T cell, colon tumors do. And when we took out DC1, what goes away are those adult origin gamma delta T17 cells, providing a really clear link, not only to this one T cell subset that's making the cytokine that causes tumors to grow, but also highlighting this weird population that really is breaking the rules and is expanding in colon tumors. And we know it's expanding because of DC1. So these adult origin gamma delta T cells and the DCs that expand them represent new therapeutic targets for colorectal cancer. And this is really exciting. And so therefore I borrowed a V Foundation's nice little slash here to highlight the outcome of research, the outcome of what can be discovered using mouse models and really dissecting out what individual cell types play, what do they do in colorectal cancer or in cancer in general. And so we're very excited about these findings. Here is my lab at one point in time fighting colorectal cancer. You can see we're on a crushed colorectal cancer run. And we were talking about the V Foundation to whoever would listen to us as we were running there. And we took nice pictures under our inflatable colon. And I definitely want to thank my student who we've been working together in this fight. And we've been thrilled with the V Foundation support. And yeah, he's very enthusiastic as I am about this work. Thank you so much, the V Foundation.
Thank you so much, Dr. Hammer. What a great presentation. And I bet everybody can understand now why it is that we love our V scholars so much. You know, if you knew Stu Scott, you would know what fun is, what love is, what joy is. What I didn't know before we started the Stu Scott Funds was his wonderful daughters, Sydni and Taelor. Taelor is a filmmaker who has many short films to her credit already. Sydni is a student athlete at Columbia. And these two young women are not only bright and beautiful, they really get what it means to change the world. And they have been remarkable spokespeople for the work that we're doing in the Stu Scott Cancer Fund. So it is now my pleasure to introduce you to Taelor and Sydni Scott. Good morning.
Thank you, Susan, so much for having us. And for sharing our Dear World video that tells part of our story. Telling stories was incredibly important to my father, and I think that it is the most important thing to me as a result. The impression and feeling of unfairness that early loss brings is one that lingers with what feels like a half-life of eternity. It's the type of pain that makes you wonder, what did I do to deserve the loss of the person who means the most to me, who supports me the most? Time and experience have shown me that this is not the whole picture, though. I'm certainly not alone in my experience, and what I have gained over the time is a redesigned appreciation for the 7 years that I got to spend with my father after his initial diagnosis. He was sick from the time that I was 12, and he passed when I was 19. But his resilience and determination to participate in as many clinical trials as would have him, as well as his desire to leave this earth with more research, knowledge, and hope for the people who would come up and have the same struggles behind him, those are the things that I look to carry forward. It's like Mr. Valvano said, it may not save my life, but it might save my child's life, and it might save your child's life. I think that now is an incredibly important time to look toward making sure there is equity and justice in the seeds we plant for the future. And I look to emulate this pay it forward mentality. It's the reason I'm so honored to really be a part of this. And I'm so inspired by the work done for and by the V Foundation, and especially the work done for my father's Cancer Memorial Research Fund. Because to me, the efforts speak to a real concept of universal human kinship that English and Africana Studies professor Christina Sharp speaks to in an essay she wrote for The New Inquiry. Now, bear with me, it might seem a little off topic, but when we read some of her work in college, what I really got from it and what really resonated for me in this particular anthropology course was her assessment that kinship instrumentally has the power to make and unmake persons and families, to assign human beings value in and of themselves. I think that the work being done is really reparative and groundbreaking and original. And it extends the ties that we feel to others around us who might not live exactly the way we do or where we live. I think it helps rend the pattern of the kinship narrative, or in other words, it uses an understanding of human radical sameness, a universal radical sameness, to extend the boundaries of kinship, care, and protection to those we might not immediately see as ourselves. This idea would become a motif for a short movie I created with the over-the-top help of my family and friends. It originated from a desire to show my father and his siblings and his family back together, because again, there's a family vibe here. It's what we care about. It's what we prioritize most. What it really became was an exercise in trying to capture the residual feelings of nostalgia, adventure, culture, and support that permeates our American experience in hopes of showing these universalities. It was supposed to be for everyone who has spent a summer playing football in their yard, an endless summer. Anyone who's fought with their siblings, anyone who has coveted a $6 million man toy at the toy store. I think the link is being attached, so if it's something that you want to check out, certainly do so. But it really was to send the message of the family vibe and the family importance of this organization. I truly can't express my gratitude or hope from the work being done by researchers, scholars, donors in the organization. It reifies for me the acknowledgement that what happens in Black communities and any minority community is a reflection of our societal values. And in addressing the issues of our most vulnerable, we build a world where we give value and cherish the time any given family has together, because we're all very similar. So this is a fight for all of us. I'd like to pass it on to my sister now.
Yeah, thank you. Honestly, Taylor, thank you so much for saying that. It was really special just to be able to hear those words from you, even though I know that this is something that we've talked about. It was really, really special to be able to hear you say that. For me, when I reflect about my dad, the thing that still today is the most poignant thing is something that is so simple. And it's just that he loved being a dad, like more than anything. He loved being a dad, especially to daughters, and so whether that took the form of tormenting and terrorizing every and any male friend, or, letting me paint his nails and wearing that proudly to work, it was something that was just so inestimably special to him. And I think that the most important way that came into play was the fact that the value he placed on my ideas and my opinions, even when he disagreed with them, was grounded in an inherent respect and value for me as a person. And so because of that, I grew up always knowing the value of my voice and the value of me as a person and the strength of my voice unequivocally. And that is the most powerful thing that my dad ever gave me. And of course, being a father to a little Black girl, it is only so long that you can shield her from that insidious truth. And it's that the world is not going to see me as inherently valuable, and with that inherent respect. So 9 months ago, I was hurdling. I'm on the track team at Columbia, and I was hurdling, and I landed wrong. And I tore my ACL, PCL, LCL, I broke some bone, I tore my hamstring, shattered my kneecap. So I'm sitting there after surgery, and I'm lying in the hospital bed in the worst physical pain I had ever experienced in my entire life. Tears streaming down my face. I'm begging for pain medication. And the nurse on duty, sort of calmly looks at me. She looks me up and down, and she says, "I think she's fine." And so, of course, my mother called my surgeon personally on her phone, had him come down to the post-op floor, and he took one look at what was going on and demanded to know why I had been denied pain medication. And for the millionth time in my life, what made all the difference was that there was someone there, in this case, my mother, who was unwavering about my inherent value to her, and by extension, the people around us. And so that story is literally just the tip of the iceberg when it comes to navigating the healthcare system as a Black person. And my experience doesn't even come close to the gravity and the relentlessness of cancer. So having heard that little anecdote, what does my individual experiences with my dad and with injuries have to do with what we're talking about here today? This past year, I was applying to a leadership position at a club at my school, and one of the questions on the application stood out to me. It said, how have you taken advantage of opportunities in the past? And that's a simple enough question, but for some reason it really resonated with me, because what it meant to me was, what have you done with the things that you have been given? And I had to look at myself and say, not enough. Because cancer took my father away. He would never see me graduate high school, much less college. He wasn't there to be the only one to reciprocate my morbid humor after I'd injured my leg. And as sad as it is, that list goes on into perpetuity. But he did leave behind his love, and he left behind his drive and his fight. And when I think about it, there are so many other things that I have been given. For example, he developed a relationship with an absolutely incredible organization that is striving literally tirelessly to make sure that my reality is different from the one of the little girl coming after me. And an organization that has pursued and demonstrated not lip service, but genuine, tangible change in the fight for racial equality, and more specifically, the most resolute commitment to closing the gap in healthcare disparities for communities of color that I have seen. And that has been what is so incredible about today, is to listen and know where that funding is going, and to know what that research is propagating is the most incredible knowledge that I can have. And so lastly, and most importantly, he instilled in me again that value in myself and in my voice. And with all of those things, I have no right to not do enough. And that's why I consider it an honor and a privilege to be able to participate in a meaningful way to the V Foundation. And I mean it that a meaningful way can mean a lot of different things. I remember this past year, my sister and I attended a panel event at Espn. And so on one side of me is the president of the V Foundation, and on the other side, or technically up on a screen, was a grant recipient. And so we have the two powerhouses in the room, and I'm 20 years old, and I have one functioning leg, and I'm thinking there's probably not a lot that I'm gonna be able to contribute. I feel a little that way today. But I just spoke to what I knew, which was my dad and his passion and his drive and his joy and his pain, and the way in which all of those qualities continue to impact me today. And after the event was over, this young woman came up to me and she told me that her mother had died of cancer earlier that month. And she said that it was the first time that she had said it in public. And when I was writing this, I thought a lot about how I would try to describe that moment in words, but the truth is that you can't. It is just this beautiful and terrible connection between two strangers. But it meant something to that woman that I was there and that I had shared my story that day. And that was one of the first times that I knew that I was starting to do something with the things that I had been given. And so to clarify, that was far from the end of it. As valuable as that moment was, this fight is deeply institutional. The solution has to be intentional. It has to be funded. It has to be structural. And that is the biggest reason why I want to say thank you again, and what an honor it is to speak to all of you today, because I am endlessly grateful to be a part, for the opportunity to work alongside people that are so committed to a cause that is so close to my heart in a way that, again, is so tangible, is so committed, is so resolute. So I'm only 20. I'm new to giving speeches, everything like that. So I admit, full disclosure, I looked up a bit about how you're supposed to work through it. And I saw that speeches can sometimes end with a call to action. And I know that and means that it's a cliche, but I figure since I'm new to this, I will just go ahead and stay the course and just do it right as the outline suggests. And so right on time, here it is. So for me, I am using that voice and that value and that sense of self that my dad instilled in me, and I'm using that to refuse to stay silent about the reality of the treatment of Black communities and Black families and communities of color and families that are made up of people of color in our healthcare system. And so what I'm asking you to do is to look at the things that you have been given, even when it feels impossible in light of the things that have been taken away. And I'm asking you to do something with the things that you have been given, and continue to do the some things that you are doing with the things that you have been given, because it is our work and it is our job to make sure that we live in a world where Black families and families of color matter in our healthcare system and in our world. So I just want to thank you so much again. I know I've said it at least 3 times now, but I cannot reiterate enough how much of an honor it is to have been asked to speak today and to be involved in an organization that is truly one of the most powerful things that I have ever seen. So thank you so much to Susan and everyone who has guided my sister and I and let us be a part of this.
Okay. Wow. As always, you two are remarkable and wonderful. I remember that day together at ESPN. And as you're thinking, what am I going to have to share? I'm like, I don't need to say anything because they have put it out there just the way it is. And we will take on that challenge. We're going to continue to work with you. This is not new to us. We're not new kids on the block, like we've all said, but the challenge is important, and there is a lot more for us to do. And we're going to do that in memory of your dad. And I got to say, Stu and Kim, you all made beautiful, wonderful children, daughters, women who give me huge hope as to what this world really can be. And together, we are envisioning what that world can be, and we're going to make it happen. So thank you both so much. Speaking of the world, let's go ahead and play the Dear World video, which is another one. And anybody who cries easily, get ready.
I can't ever give up because I can't leave my daughters. The best thing I've ever done, the best thing I will ever do, is be a dad to Taelor and Sydni. I love you guys more than I will ever be able to express. You two are my heartbeat. I am standing on this stage here tonight because of you.
The hardest part of losing my dad has been times when I either thought I saw him somewhere, and when there are things that I want to tell him.
I would like to thank him for liking me. For all the times that people haven't really liked me, he really liked my personality. He said, "You're my favorite person." And so to just be loved that way.
Isn't that a remarkable piece that says so much in one short minute? Again, thank you to all of the Scott family for being here with us today. So most of you who are listening know that translational research helps bridge the gap between what we're learning in the laboratory and what makes a difference in the lives of human beings. And our first speaker is Dr. Kishore Gouda, who is a veterinarian and a PhD, who is at Case Western. And he is looking at the mutational signatures of African American colorectal cancer, and also just doing some very interesting work. We look forward to hearing from him. Dr. Gouda.
Thanks, Susan, and really
good morning.
Honored and humbled to be part of this group. I hope that you're seeing my screen. You know, I was listening to and Taelor Scott, you know, as someone who lost his dad, you know, when I was a teenager, at least I can understand the vacuum that it creates. He passed away due to a disease. And this is also really personal to me, and can we do something about it? So today I'm just gonna talk briefly about some of the work we have been doing to understanding the colorectal cancers, particularly in African Americans, more from a molecular angle. This is a recent statistic from American Cancer Society. The number of folks that will be diagnosed with colorectal cancer, and a third of them would likely die from the disease. But more importantly, what we have seen and known is that the African Americans still continue to exhibit the highest colorectal cancer incidence as well as mortality rates. So there seems to be a clear unequal colorectal cancer burdens in that population. And as shown in this graph, you will see, if you consider the incidence as well as the mortality rate per 100,000 people, and if you focus on these two groups, non-Hispanic whites and non-Hispanic blacks, you can see that the African Americans do have a 25% increase incidence of the colorectal of this disease, both in men and women, as well as an increase in up to 50% mortality rates in both men and women. So clearly, the African American population are disproportionately affected by this cancer. What is also an interesting fact is that typically colorectal cancers in the general population, or if you take Caucasians, you would often see them in the left side of the colon right here. But what is interesting is in African Americans, these cancers tend to be formed on the right side of the colon. So there could be potential genetic or molecular differences or microbiome, as we have heard from the previous scholar speakers, that could be somewhat contributing to this differential anatomic site where you often see these cancers. Of course, as we all know, I think the biggest factor for some of these disparities or the unequal burdens is socioeconomic and access to care factors. One of the things that we are doing at our cancer center is also having these researchers go on listening to tours in inner cities, where we go and talk to these wonderful old ladies and sort of in an informal chat. And what I often hear is, I couldn't get a ride to the hospital. I didn't check at the right time. There are also economic factors preventing them from getting the access at the right time. So I really think there's clearly the majority of these is due to these socioeconomic as well as access to care. But given these differences, what I just alluded to, could there also be molecular differences in these tumors that could potentially contribute to these unequal burdens? So when we asked this question and we looked at the databases, specifically TCGA and other databases, what we found is there is a dearth of, these cancers being represented in the public domain or in the public databases or cancer databases. And we also found they are being understudied, the cancers arising in these ethnic groups. So we therefore initiated a study to perform some in-depth characterization, at least at the molecular level, specifically on colorectal cancers arising in the African American population. So we used a high throughput genomics approaches, and through our hospital, we are able to accrue or 100 African American as well as Caucasian colorectal cancers as a comparator to study the molecular landscapes. So and as an initial approach, we're trying to look at what we call as genomic copy number alterations, meaning in cancers, you do often see that some certain regions or some genes, they tend to increase in their copies. It's basically you're copying and pasting the same gene over and over again, that you won't see that in these normal cells. So we initially wanted to profile these, what is the landscape of these copies that you see in the colorectal cancers in African Americans, and using a genome-wide approach. So at that point, we were not happy with the algorithms that are available to profile these things. So we came up with a new algorithm. It took us 6 months, where we developed this program called Envy, that can specifically look at these alterations in a clinical tumor sequencing data sets. And using this algorithm, so we then fed the genomics data from the colorectal cancers and try to look at the alterations. So shown here in this graph on the top are these chromosome numbers, actually, including X and Y. Red indicates a particular region or a gene has gained more copies, whereas blue indicates a particular region or gene that has lost one of the two copies. So on the y-axis, you will see the frequency, what fraction of the cancers that we are seeing such events. What we found, at least in this graph, this is typical of colorectal cancers. All these regions, the chromosome 7, chromosome 13, loss of chromosome 18 region. These are all highly typical of and well known in colorectal cancers. But however, we also found certain regions of focal alterations, very pinpointed alterations that we were not able to detect or identify in cancers from the Caucasian population or in the public domain. So currently we are actively focusing on these regions to further categorize these things. Then as a next approach, what we found is, in addition to or what we wanted to attempt is to, in addition to these copy number alterations, can we also look at the errors or the mutations in certain genes in the cancers, which is a well-known underlying phenomenon, how cancers do develop due to these genetic alterations, or we call the genetic accidents. So I'm not going to go through this entire thing of how we developed this, but the outcome of that is, if you look at the most well-known or well-characterized cancer driver genes, there are 6 or 7 of them, at least in the colorectal cancer space, but many of these genes are as well altered in other types of cancers outside of colon as well. So these are well-known cancer driver genes. So we compared the mutation frequencies of these genes among African American, the Caucasian population. While we did not see much difference, in terms of frequency-wise, what we found is this particular gene, KRAS, which is actually an oncogene, well-known oncogene, and there are also active clinical trials going after, how do we target the RAS oncogene as a potential targeted therapy for colorectal cancer. What was interesting is that we found a higher frequency of RAS gene mutations in African Americans compared to Caucasians. And we have done this study, we have replicated this study, and this effect is not only in our study, but also studies performed across the nation. There are a couple of studies that were done in African American colorectal cancers, where they have also reported a higher frequency of RAS oncogenic mutations. So in addition to these well-known cancer driver genes, then we asked, are there other genes in the cell? You know, there are roughly like 20 to 30,000 genes. We asked, there are other genes that are showing these differences in frequencies, mutational frequencies, other than the well-known cancer driver genes. In fact, we did find a set of 15 or so genes showing a higher mutational frequency in African American colorectal cancers. For example, mutations in these 15 genes accounted for up to 40%, 41% of African American colorectal cancers, as opposed to only 15% of Caucasian CRCs. Now, once you find this, you know, could there be a clinical significance or association for this difference of mutational frequencies in these 15 genes? It turns out that if you are mutated, or if those tumors have a mutation in any of these 15 genes, those tumors tend to recur at an early time point than those that did not have mutations in these 15 genes. So if you consider both early stage 1 up to 3, as well as stage 3 cancers alone, colorectal cancers alone, we found this clear distinction or demarcation where mutations in these genes, those cancers tend to recur sooner than those that do not have these mutations. One of those 15 genes is known as FA6, and I will tell you why we are interested in this. And we also are thinking this could be a potential novel colorectal cancer driver gene. And this is just showing the protein structure of the FNA6 and these mutations in that gene. But this gene belongs to what we call an Ephrin receptor superfamily of tyrosine kinases in the cell that perform various different functions in health and disease. And not only that, 2 of these members related to this Ephrin family were previously identified as a significant genes that are mutated in Caucasian colorectal cancers. However, until now, the role of this particular gene, remains unknown. So we pursued studies in characterizing the biologic significance or role of this gene in colon and during cancer development. So shown here is a cell. This is the cell membrane and the nucleus. So FNA6 is a receptor tyrosine kinase. It relays the signals from outside into the cell. There are certain changes, biochemical changes that happen when it binds to its preferred ligand, and then it transmits the signal into the cell. It does this by bringing in more partners and then relaying that signal to intermediary partners, and then those go into the nucleus and then bring about changes of certain genes that can express as a particular phenotype, or a function. So since we don't know anything about this, our goal was to understand what the binding partners are, signaling mediators, or what are the downstream targets, and what would be the phenotype. And similarly, we are then studying how the normal receptor can differ from these mutants that we identified in African American colorectal cancers. So using a series of high throughput proteomics, genomics, biochemical assays, what we found was at the receptor level, where you induce a chemical change, we call it the phosphorylation, that is essential for the activity of the receptor. A couple of these mutations that are derived from the colorectal cancers showed complete loss of that activity. We also found differences in the binding partners between the wild type as well as the cancer. We also found alterations in these genes and the downstream involved in inflammation, metabolism, energy balance, etc. So currently we are focusing on how these mutations alter the properties or potentially respond to standard chemoradiation therapies. We also developed mouse models where we knocked out FNA6 or induced a mutation, engineered the mouse models with these mutations. Here is an example. When you delete FA6 in the colon, you would see an altered length of the colon crypt. This is just a microscopic image of the colon, how it looks if you delete the FA6. We also find, interestingly, there is an increased proliferation or the growth rate of these crypts when you delete this particular gene in the colon, and also how some of these mucins, these are just the composition of these mucins that play an important role in normal colon maintenance differ. So currently we are looking at the characterization of these colon mucosa. We're also trying to study the outcome of this from a colon cancer perspective, using a spontaneous or carcinogen treatment, or crossing these mice with the APC driver gene model. So the significance or applications is basically what we learned. If you do in-depth studies in tumors, there is a potential to identify or reveal, unravel new cancer genes. If those 15 gene mutations that we found behaves differently or more aggressively, we can actually establish some early testing strategies or treatment strategies to those patients. Or if the chemical mutate, the pattern, what we call the signature of these genetic mutations in these cancers, are the result of environmental or dietary carcinogen, then we can instigate epidemiologic studies to potentially identify the source of exposure, providing strategies for chemo prevention. And finally, with the Espn in particular, it is a hot topic under active investigation as a target for cancer therapy. So our studies in the FA6 preclinical models could open new avenues for targeted therapies in cancer patients. So with that, I would like to end. Particularly, this work is being led by two of my postdocs, Sri and Durga, and these are all my collaborators from CASE, Joe Willis, Sandy, and Vinay. And truly grateful to the V Foundation, also to the NIH Center for Reducing Cancer Health Disparities, and to all these patients. I think I might have gone overboard, but thank you so much for your time.
Thank you very much, Dr. Gouda. It was great and well worth the extra few minutes, so thank you so much. Our next presenter is Dr. Adam Murphy. Dr. Murphy is an assistant professor of urology at the Lurie Comprehensive Cancer Center at Northwestern, and he's going to talk to us about his research that studies prostate cancer risk in African American men. And he's recently been looking at the correlation between vitamin D deficiency and prostate cancer risk. He wants to help men understand both what their risk is of developing prostate cancer and also how it is that they can prevent existing cancers from getting worse. So welcome, Dr. Murphy.
Good morning.
Good morning.
Thank you. I guess so first of all, thank you for the V Foundation for funding this research, which I think is really important to trying to help reduce disparities for African Americans at risk of prostate cancer. I guess I am going to talk to you about the purpose of why we do this study. I became aware of the fact that biomarkers are great in that they help us kind of detect disease and also spare people who don't have the disease from invasive tests like biopsies. And that's been one of the things that PSA has had a problem with. Prostate-specific antigen has been the key biomarker for detecting prostate cancer. But as we've gone on in time, it's had a higher mandate to not just detect all prostate cancers, but really detect the ones that we care to treat that were potentially lethal, and kind of ignore the ones that were indolent or not likely to kill someone in their lifetime. And so one test that helps us to do that is called Prostate Health Index, which has been validated multiple times in American and European populations, mostly comprised of whites, but also several Asian groups have done similar work and shown that it works in their populations as well, but you have to use different cut points for this test. The test on average goes between 0 and 150. And if you use various cut points, you can help people avoid unnecessary biopsies by reducing the number of false positive tests. So we want to see if it is accurate in Black Americans, and then to see if the threshold is the same. The reason why I thought that there could be a problem was that the prevalence of prostate cancer is a lot higher in Blacks compared to other racial groups. In whites, the incidence is about 123 per 100,000 for white males, and 19.9 per 100,000 is the mortality rate for prostate cancer. If you compare that to Blacks just to the left, it's the incidence rate, or how often it occurs, is 70% higher, and the mortality rate is about 2.5 times higher. So whenever you have a difference in prevalence, the thresholds you use to detect, call it a positive test, may need to change. So I call this the Goldilocks problem, where you want it just right. So on this top left graph, this is how PSA performs in whites, where you have people with disease in orange. This is the distribution of PSA in white males with prostate cancer that's potentially lethal. And then this is the distribution in green of people who don't have prostate cancer. And if you see here, there's overlap between those two distributions, which makes it's not a perfect separator of the groups. So if you picked a point in the middle of the disease group, you have absolutely no false positives, meaning that every person with a PSA above that level would have prostate cancer that was significant. If you picked a point in the middle of the people without diseases distribution, here, let's say a PSA of 1, you would be able to detect everyone who had the disease, but you'd have a lot of false positive tests as well, meaning people without disease will be recommended to have a prostate biopsy, which is painful and invasive. So we'd like to avoid that. And we have to have this trade-off between detecting enough of the prostate cancer that are significant or potentially lethal, but also avoiding unnecessary biopsies in people without disease, which is this area here. So the Prostate Health Index is a combination of PSA, free PSA, which is its free-floating non-protein bound version, and then a pro-hormone version that's made more by cancer cells, called -2 Pro PSA. It's been shown to be more specific in detecting all prostate cancer and potentially lethal prostate cancer, and it's included in the National Comprehensive Cancer Network's prostate cancer screening guidelines at a threshold of 35. So above 35 being people who are test positive who would be referred for a biopsy when they have an elevated PSA less than 10. So I got concerned about guys who come to my clinic as a urologist with elevated PSAs, and I wanted to know for them whether Phi works similarly and better than PSA in detecting potentially lethal prostate cancer in Blacks. And should we continue to use the 35 cutoff that's recommended by the FDA and by the National Comprehensive Cancer Network? So to do this, the V Foundation funded me for 3 years to try and recruit biopsy-naive Black and white men to see if this test worked, to validate its accuracy in Blacks. So we recruited 208 men who had an initial biopsy for their elevated PSA. We got them right on the day that they were getting their biopsy and drew the blood right before it so that the needle wouldn't affect the PSA levels of the Phi test. And we did the same in whites. And then to see how this would affect people who would be screening for prostate cancer, the National Cancer Institute funded a center in Northwestern to do pilot studies where we were able to go into the community and recruit healthy, controlled Black men, actually at a lot of softball games and community events like churches, educational activities. So we recruited 140 Black healthy controls. We did not do the rectal exam in the community, but they did not have prostate cancer. never had an episode of elevated PSA, and they did not have a history of an abnormal rectal exam. So we think these people have really low risk of prostate cancer. The main differences were that the men in the healthy controls were younger on average, and they had a lower rate of family history of prostate cancer, which was expected. So this is kind of our first proof that prostate health index works similarly in Blacks and whites. The red are the African Americans in the biopsy group, and the blue are the whites in the biopsy group. And as you see, as phi goes up by 10 points, the risk of potentially lethal prostate cancer goes up in a very linear fashion for both Blacks and whites. There seems to be a trend that Blacks maybe have higher levels of prostate cancer that's potentially lethal at each of these groups of 10 for the prostate health index. So there's more prostate cancer in each group of 5. So this is a very busy slide, but I want you to pay attention to the far left part of this table and the far right. The far left is actually what's reported on every report that a patient gets when they get their prostate health index result back. If they'll get a score between 0 and 150, and it will say if their phi score falls between 0 and 27, they have an about 10% risk of having any cancer. And if you get up to greater than 55, they have a 50% risk of having cancer. Well, compare that to what's happening in Blacks, you'll find that the rates of any prostate cancer, at least in grade group 1 through 5, which is all prostate cancer, is a lot higher by the time you get to 27 to 36. So it's 17 versus 45%. And then if you went to greater than 55, the rate of prostate cancer is 68% in Blacks versus 50% in a mostly white population that is used to report to patients their probability of cancer. So I would say this isn't very accurate for Blacks. For the people who have the potentially lethal prostate cancers, the 2 to 5 prostate cancers, we see that that actually is much more similar to the all prostate cancer in whites, which is reported as the general population here. So essentially, Blacks should expect to have potentially lethal prostate cancer at the same rate that the general population has any type of prostate cancer. This is an accuracy plot, essentially called a receiver operating curve, that shows that the accuracy of prostate health index is, let's say, 64%, and whereas PSA is only 58% accurate. So it is a little bit better than PSA in Blacks. This is the main thrust of this presentation. If you looked at a PSA by itself and the people who are having biopsy, the typical threshold that we use in the US is a PSA greater than 4 will prompt a prostate biopsy. So if you use that in Blacks, it would detect 92.5% of the significant prostate cancers. It would be specific in 9.5%, meaning that it would help 9.5% of men avoid an unnecessary prostate biopsy. And those healthy controls we recruited from the community, 7.4% of these men would have been referred for an unnecessary prostate biopsy. So we spare most controls an unnecessary prostate biopsy with a PSA of 4. When you use phi after PSA of 4, you could, and we use the FDA threshold of 35, that sensitivity, which is the detection rate, falls to 86% for Blacks. So that means you miss 13.4% of significant tumors in Blacks, which is fairly high to miss 1 out of 7 tumors that could potentially kill someone. And the specificity in this space is really good, though. It's 3 times higher. So you avoid 30% of these biopsies that are unnecessary. This is an interesting trade-off here. If you go to a lower threshold of phi, I think that we should probably be using a threshold of 28 in Blacks to preserve the detection rate so that you can pick up 92.5% of these tumors that are potentially lethal, just like PSA alone. And you can increase the amount of men who don't need a biopsy by about 70%. You go from 9.5 to 16.5% missing an unnecessary biopsy. And all these numbers only would unnecessarily biopsy 6.6% of controls. So it's safer for the controls to use fine. It does preserve the accuracy or the detection rate of clinically significant or potentially lethal prostate cancer, and you do spare some more men unnecessary biopsies. So I think that the FDA threshold needs to be lower for Blacks is the take-home point. I would like to thank Stuart Scott for his leadership in cancer research, and of course the V Foundation, and the patients who participated in the community and in the clinics, and really I appreciate the opportunity to speak today. Thank you, and I'll take questions at the end.
Thank you, Dr. Murphy, so much. That was really, there is so much more that we need to know in prostate cancer and with PSA in general, and especially these differences between Black and white men, which will make a difference right away in what goes on clinically in taking care of these patients. So thank you very much for your presentation. Thank you. For this afternoon session is Dr. Russo Torres, who is currently at the University of Southern California, but got this grant along with Dr. Vered Stearns at the Sidney Kimmel Comprehensive Cancer Center at Johns Hopkins. And they are doing some fascinating work at looking at the immune system, possible ways that can be used to help treat breast cancer. So we welcome her and look forward to hearing a little bit more about your work. Thank you, Dr. Russo Torres.
Good morning. My name is Evanthea Russo Torres. I'm a medical oncologist and translational researcher at the University of Southern California, previously at Johns Hopkins University. And thank you for inviting me to share an update about our phase 1 study of entinostat and nivolumab with or without ipilimumab in advanced solid tumors. This morning, I'm going to discuss the significance of this study as well as some background regarding the role of the immune system in cancer. I will then present the clinical trial methods, results, and conclusions, as well as discuss some of our future directions. We begin with the significance of this work. I'm sure I don't need to convince you all that cancer is a significant global issue. In 2018, 9.6 million people died as a result of their cancer. Cancer is also the second leading cause of death globally. While we have a number of therapies that can help prolong the lives of people with cancer, we're constantly seeking better ways to improve response rates. New therapies such as immunotherapy, which we've heard a little bit about from my colleagues as well this morning, they give us hope toward more durable responses and more lives prolonged than ever before. The goals of therapy in some cases are to cure disease. In those who cannot be cured, we aim to improve time to progression and overall length of survival. We're always thinking about ways to control symptoms, both from a patient's cancer as well as their side effects suffered from treatment. Our overall goal is improvement in quality of life. The medical community has been studying the body's natural immune defense against cancer for decades, but only recently has immunotherapy had some success in treating certain types of cancer. The most success has been observed in lung cancer and melanoma, and thus there's great need to expand the efficacy of immunotherapy to patients with other types of cancer. The goal of immunotherapy, and specifically checkpoint inhibition, the type of immunotherapy we will discuss today, seeks to boost the immune's natural immunologic defense against cancer. Here you see tumor cells growing within an organ. The goal of immunotherapy, and specifically checkpoint inhibition, seeks to boost the body's natural immunologic defense against cancer by retraining immune cells, such as T cells, macrophages, and dendritic cells, to fight the growth and spread of the tumor. Whenever we discuss the role of immunotherapy in any kind of cancer, we first need to define the tumor's immunogenicity. Immunogenicity refers to whether a tumor has immune cells that reside within it at baseline. Such tumors are often referred to as immunogenic or hot. As these tumors grow, they often recruit immune cells, as shown here. You can see T cells, macrophages, and dendritic cells. These are all immune cells that naturally fight foreign growths and infections within the body. Checkpoints are molecules on both tumor cells and immune cells that ultimately pump the brakes on the immune response, which is how tumors are allowed to progress. The addition of checkpoint inhibitors, such as nivolumab and ipilimumab used in this trial, can reverse this process by leading to the activation of T cells, which causes them to regain their anti-tumor effect and lead to tumor cell elimination. In short, in a tumor that is considered hot, as a checkpoint inhibitor can release the brakes and allow the immune system to do what it is meant to do and kill the tumor. The types of tumors that work this way include certain types of lung cancer and melanoma. However, many tumors that have not yet benefited from immunotherapy are actually considered non-immunogenic or cold. Cold tumors have little to no infiltration of T cells and are often infiltrated with immunosuppressive cell types such as T regulatory cells and myeloid-derived suppressor cells, called MDSCs. The presence of these cells prevent the anti-tumor immune cells from entry and/or activation. This ultimately leads to a tumor microenvironment that is immune suppressed. One way to improve response rates in these cold tumor types is to try and transform the cold tumors into hot, to transform non-immunogenic tumors into immunogenic ones. It has become clear that single-agent therapy with checkpoint inhibitors has not been able to transform many tumor types. Thus, new drug combinations that target the immunosuppressive cells are under investigation. For example, in our trial, the drug entinostat, an epigenetic modulating drug that alters gene expression in many different cell types, was used in combination with checkpoint inhibitors nivolumab and ipilimumab. The idea is that the addition of entinostat decreases immunosuppressive signals and increases recruitment of the immune cells that allow checkpoint inhibitors to turn on an anti-tumor effect and thus eliminate tumors. To review, the overall strategy of this type of combination therapy is to take cold tumors and change the microenvironment, turning them into hot tumors that ultimately are more sensitive to therapy with checkpoint inhibition and thus tumor elimination. The treatment strategy was first studied in the lab. Mouse models of cancer were used to investigate the drug combinations of entinostat plus checkpoint inhibitors, nivolumab and ipilimumab. In these models, we were able to observe cold tumors transform into hot tumors. This led to improved survival and decreased tumor growth in our mouse models. This work was published and provided the rationale for the design of this clinical trial that sought out to test the safety and efficacy of this therapeutic combination in patients. So moving on to the clinical trial design. This trial included two cohorts of patients. Both cohorts enrolled patients with locally advanced tumors who had progressed on multiple other lines of therapy. The first cohort was part of a dose escalation, and the second cohort was part of a dose expansion and was completed in patients with breast cancer. Patients were given 2 weeks of entinostat as a way to begin the transformation of the tumor microenvironment. Then they received 8 weeks of immunotherapy with checkpoint inhibitors, either nivolumab alone, and some with the addition of ipilimumab as well. Patients agreed to tissue biopsies and blood draws at 3 time points illustrated here. 0 was baseline. The first time point was 2 weeks after entinostat run-in, and the second was after 8 weeks of combination therapy. Biopsies were evaluated for a number of things. Represented here are stains which show biopsies at each time point. These biopsies are from a patient with adenoid cystic carcinoma who had an increase in immune cells. Those are the cells that you see in deep purple after receipt of combination therapy. In the first cohort of patients, the dose expansion cohort, patients were treated with 4 different dosing levels, each with different dosing of the drug combinations. As you can see, all patients received entinostat and nivolumab. However, only those who received level 3 and 4 were given ipilimumab as well. I apologize, you can hear my dogs in the background. So the primary objectives of the trial were the safety and tolerability of entinostat and nivolumab plus or minus ipilimumab in advanced solid tumors, as well as determination of the recommended phase 2 dose of the treatment combination. The secondary objectives included change in the ratio of the anti-tumor T effector cells to regulatory T cells, a ratio that has been shown to correlate with immune response. Also, evaluation of the anti-tumor activity for response evaluation criteria in solid tumors called RECIST, as well as immune RECIST. The manuscript reporting these objectives is in preparation. So now I'm going to summarize some of the results. There were 35 patients enrolled in the dose escalation cohort and 15 breast cancer patients enrolled in the dose expansion. All patients' time points have been collected, and the results presented here represent analysis of the first cohort. The patients all had good performance status, noted by ECOG 0 to 1, and they represent 6 different tumor types that are listed here. All the patients received between 0 to 14 prior therapies. The most common side effects observed included fatigue and nausea. Dose-limiting toxicities occurred in 2 patients, one patient who had lung inflammation and one who had an allergic reaction. Immune-related side effects are similar to those that have been previously reported by others and include things such as altered thyroid function and inflammation of the GI tract, all of which were treated and patients recovered. Based on the evaluation of this safety data and discussions with the sponsor, the recommended phase 2 dose was determined to be dose level 3. The objective response rate observed in the first cohort of patients, the dose escalation cohort, was 15%. This included a complete response in a patient with triple-negative breast cancer and partial responses in hormone receptor-positive breast cancer, cholangiocarcinoma, and high-grade undifferentiated pleomorphic sarcoma. The change in T-cell infiltration was measured using immunohistochemical stains, which turned T-cells brown, as shown in these images below. As you can see, the brown anti-tumor T-cells increase in number once the patient has received all 3 drugs, as shown in time point 2. Quantification of the T-cell infiltration showed a significant increase in the ratio of different types of T-cells between time point 2 and time point 1, as well as between time point 2 and baseline. This indicates that immune infiltration increased in response to therapy. In conclusion, the combination of entinostat with nivolumab plus or minus ipilimumab appears safe and tolerable with expected rates of immune-related adverse events. The T-cell ratio was also found to be increased after combination therapy, which suggests this could be an informative biomarker of immune infiltration. Future directions include completion of evaluation of the clinical data for both the dose escalation and the breast dose expansion cohort. In addition, there are treatment-specific effects within different cell types in the TME. Future analysis will identify transcriptional patterns that are enriched in response to combination treatment. We're currently using powerful genomic sequencing tools called single-cell RNA sequencing in order to determine all of the cell types within the tumors and the different gene expression patterns as a result of therapy. These kinds of powerful experiments will help us learn from these types of important clinical trials to improve the use of immunotherapy for patients with many different tumor types and ultimately improve survival. I'd like to thank the study teams at Johns Hopkins, especially the principal investigators of the study and my mentors, Dr. Roisin Connolly and Dr. Vered Stearns, as well as our partnering PIs at Yale, City of Hope, and University of Pittsburgh. Also, a big thank you to the V Foundation, whose funding has greatly contributed to our work. Lastly, a special thanks to patients who participated in this study and CTEP at the NCI. Thank you so much.
Thank you so much, Dr. Russo Torres. That's very hopeful data that you have, and glad that you are working to help out with the huge number of women who are diagnosed with breast cancer in the United States, and especially those cancers that disproportionately affect Black women, women of color. So thank you. Thank you to all of our presenters. I think you should be able to see all of them now on your screen. We have a few questions. I know we're just past noon and some of you may need to sign off, but for those of you who could stay, I will ask the questions directly of the investigator for whom they came in. So let's start with Dr. Hammer. Dr. Hammer, are superfoods cancer fighters? Are they truly a valuable thing to add to your diet?
I love this question, and I'm not an MD, so maybe the MDs will cringe when I give my answer. But my honest opinion is we have to think and realize that cancer comes in part from our genes. It's true, but there's also a strong influence of the environment, and that includes our food, that includes air pollution, many, many things. And so in my thinking, it could not hurt to have a nice diet.
Would any of the other physician investigators want to comment on that? Okay, seeing no hands raised. Oh, yes, okay, Dr. Murphy, thank you. I see your hand raised.
So for sure, diet plays a huge part in kind of your long-term diet plays a huge part in how you live with cancer, how you prevent cancer. We actually started a program called Good Food is Good Medicine in Chicago, trying to get people to be aware of that diet connection. So eating the right diet had been kind of epidemiologically assessed, and people think that you gain about 8 years of life expectancy if you were eating the right diet. So, you know, high red meat intake and processed meats is a no-no, and kind of being towards a plant-forward diet. You don't have to be all the way vegan, but you know, 3 to 5 servings of fruits and vegetables a day with low fats and low processed meats would be ideal for cancer prevention. And there's some evidence for certain specific nutrients impacting like cancer risk, like vitamin D, for example, zinc, cadmium, things that are harmful exposures to.
Thank you very much. The next question is for Dr. Torres. Does the state of your immune system have anything to do with whether or not your immune system responds well to cancer?
Thank you so much for the question. So yeah, this is a great question and something that comes up a lot. I think the way to think about this is really that it depends really on the response of your immune system to specifically the tumor. So certainly how your immune system responds to things like the common cold, or even, you know, other things like autoimmune disease, definitely plays a role and gives us a kind of a window into a person's specific immune response. And I think that's part of what we're trying to figure out in the lab and in the preclinical world, is that how do those immune responses to more common things like the common cold, or less common things like autoimmune disease and cancer, how do they all play a role in the overall response, the overall anti-tumor response? So unfortunately, I don't think that there's a straightforward answer. I don't think we can say that if you catch a lot of colds, you're less likely to fight a tumor. I think in some ways it actually demonstrates that you have an active immune system. It's just that, you know, you may not have the right antibodies to fight a specific virus or a specific cold per se. But I don't necessarily think that directly translates to how your body would fight cancer. I think that's going to be a specific response to the tumor that might be growing. So we're still learning how it all works.
I was going to say more to learn, and thank you for helping us learn more and know more. The next question, Dr. Ojicina. Can you talk a little bit about what drew you to breast cancer, and whether or not you think that the work you're doing is and or will be applicable to other kinds of cancers?
Thank you very much for that question. So those two things are actually somewhat related. You know, sometimes one of the challenges I have is when people ask me, what kind of cancer do you study? You know, so it turns out that I actually do a lot of women's cancers, but I'm more interested in the concept rather than specific cancer. So indeed, what we're hoping to do is ultimately to extend the study of this paradigm to all cancers, really. We think that there are going to be applications. They could have various levels of applicability, but I think almost every cancer will have some application with respect to this paradigm. With respect to breast cancer, it was somewhat of a professional traumatic experience. So my very first patient as a physician had breast cancer with metastasis to the brain. And at the same time, her younger sister also had breast cancer. And they died within 3 months of one another. And that to me was just, we have to do something about this. So really, that for me was really what's, I mean, there were other factors, obviously, but you know, so I still see her face, you know, but their faces really, you know, and you know, so with respect to breast cancer in particular, I think it was just that literally the very, very first patient I saw as a physician, you know, and so that has stayed with me all these years.
Thank you. That's a very touching story. Dr. Murphy, do you think that prostate cancer among Black men occurs at younger ages? Are younger men increasingly at risk for prostate cancer based on your model?
That's a good question too. The answer from autopsy studies looks like it's similar rates of kind of indolent prostate cancers by age group, but it just seems to progress faster to being detectable and then being clinically significant. So the prevalence is quite a bit higher when you get to that detectable phase of prostate cancer. And that's been shown before multiple times. We actually tried to figure out if it was similar in Nigeria a couple of years ago, and we just are publishing that now. But it looks like the rates of prostate cancer are in Nigeria, which is an ancestral population for African Americans, is lower than American Blacks, and actually lower than American whites. So it gives us this idea that there's like something about maybe genetics and environment happening in America in itself that's increasing that prevalence. There's a lot of people who would argue that Black men should not begin prostate cancer screening at age 55 like the general population, but should start in their 40s because of the higher prevalence of when it's detectable.
That stands to reason. Thank you very much. And a question for you, Dr. Gouda, that's come up. Tell us, if you would, a little bit about the various genetic mutations that predispose to colorectal cancer, and do you regularly test patients for these mutations, or are they regularly tested, and how has that played out in your research?
So I think that is an important question. You know, there are two things we are talking about here. One are the mutations that we see only in the tumor cells, but not in the normal cells. These are just tumor specific. So those tumors, when you resect them, when you sequence those tumors, you find these mutations or accidents, and where now those could help you in understanding or developing potential new biomarkers, you know, blood-based or stool-based biomarkers, as well as some of these mutations can be amenable to some targeted therapies. So in the therapeutic space, mutations in these tumors help us a lot, and that's where the sort of personalized genomics is going forward. The other angle is the genetic predisposition. You know, people who are born with certain genetic variants, right? And that's also a large part of my study and our group here at CASE. We are doing a lot of familial genetics, both in the colorectal cancer as well as esophageal cancer space, thanks to support from Katie Couric and her organization. There, the advantage is you find these predisposing or genetic susceptibility genes. Now you can screen those populations at a very younger age, you know, based on the family history. And then you can now implement certain preventive strategies. You know, like for example, colorectal cancer, you know, can you take baby aspirin or change your lifestyle, or undergo more screenings at an early stage, you know, put on a program so you can prevent or delay the onset of these cancers. And I can tell you an example where we have done that, a couple of examples, where one specifically where we are looking at this family that had a weird genetic disease, but also their aunts and their dads had this an aggressive form of colorectal cancer. And when we sequenced these, his nephew is like 23-year-old, and we found the same mutation, and we actually called the mom to take the 23-year-old for a colonoscopy. And fortunately, she listened to us. The kid goes to the colonoscopy, they find 2 large serrated adenomas in his colon.
Wow.
So that's the power of genetic predisposition and the space that you can work through, where you can now prevent, remove it, and then put the kid in a surveillance program, as well as altering lifestyle, dietary factors to prevent it. So 2 different areas, but both, you know, are equally important.
Well, thank you all again so much for taking part in this. Thank you to our audience for sticking with us. I hope you've enjoyed it as much as we have, and for being patient with us through a few of our technical glitches. But gosh, I think everybody did a great job. So thank you. We're going to be also putting up on the screen, we're having a second seminar this afternoon featuring some of the researchers in our Robin Roberts Cancer Thrivership Fund. That'll begin at 2:30, and you should be seeing, in just a moment anyway, the slide coming up on your screen that gives you the login information for that. Thank you again, everyone. Enjoy the rest of your day. And to all of you doing this research, we just appreciate you so much. We know that you're helping us achieve victory over cancer, and particularly in the work that you're doing to help diminish the disparities that we're seeing that are devastating, and that we really believe through your work and research we can make changes. Thank you again. Wishing you all the best.